Hello and welcome back to today's guide. I'm your host Nathan, and I'll be guiding you through Bandit level 24 to 25 on Over the Wire Bandit Challenge. So when we go over to the page, we see that it tells us that Damon is listening on port 30,002 and will give you the password for Bandit 25 if given the password for Bandit 24 and a secret numeric 4-digit PIN code. There is no way to retrieve the PIN code except going through all of 10,000 combinations called brute forcing. So for this challenge, we will have to understand some low-level networking concepts and also write a script to go through each combination and figure out what the PIN code is so we can actually get that password. Before we actually start writing the script, we want to understand what the daemon is actually doing. So let's try to connect to the 30,002 port using netcat. So if we netcat localhost 30,002, we'll see a message. I am the PIN code checker for user bandit 25. Please enter the password for user bandit 24 and a secret PIN code on a single line separated by a space. Now this is the first major obstacle that we had to go over through, is the format that we have to send the message. So it says the secret PIN code needs to be sent on a single line separated by a space. Now this is very important because if we don't do that and we send the message, we won't receive a response and it will just time out like how it did right now. So the good thing is as long as we keep sending messages, it won't time out. So let's send an example here. We'll send bandit 24's password along with a 4-digit PIN. So let's just use 000. And it says wrong. Please enter the correct PIN code. Try again. So in reality, this is what we want. We just want to cycle through 0001, 0002, all the way up to 9999. And once we get there, we'll have tried out all the possible combinations, and hopefully we would have gotten the password by then. So there's a lot of ways to do this. We can always use Bash or some other scripting language, but I'll be using Python 3. That's just the language I'm most comfortable with, and honestly, it's almost perfect for this situation. So yeah, we'll go over how to write the script and how to improve it. So in Python, there's a lot of ways to add padding to integers. In newer versions, there is a more cleaner way to do this, but since the machine hosting Bandit 24's account is hosting Python 3.5, we'll be using an older version called zfill. And zfill is basically made to add zero padding to numbers. That's its whole purpose. So we have this function 1, and we assign the number 1 as a string to the variable number. And we simply just assign it to a new variable called pad and call the function zfill with the number 4, which is the maximum amount of length we want this pad to be. So then we just print the pad and to see what it looks like, and then we'll print the type just to show you that it doesn't print out or it doesn't produce a integer, it produces a string. So we can just run that, and just like that we get 0001, which is exactly what we need. And just to show you, it is a string, so which is perfect because when we're sending things over the wire, we want it to be a string first, then we'll convert it to bytes, so we can actually send it over the wire. Now I know this challenge might seem more difficult than the previous challenges, but at the bare bones it's very simple once you get to understand it. If you don't know many of the terms that it's throwing at you, like brute forcing or the daemons or networking terms, and you feel a little lost, I highly recommend that you research a little bit more and try to learn Python. Python is an incredible tool. It helps you a lot in the cybersecurity field. But even if you don't know, I still highly recommend to watch this video. I will try my best to explain each line of code and what it's doing, and hopefully in the future you can write something similar and pass this level. But if you are just a little lost, don't feel bad just to skip this level, and in the future maybe come back to it. So the first library that we want to use is socket, and socket is a very useful library in Python. It allows you to do a lot of low-level networking. And so at the start of the script, we're going to declare we're going to import socket, and we're also going to, well, you don't have to do this, but I did this, import datetime, and that's just to time the script and see how long it takes. You don't have to do this, you could just import socket if you want. But then we start with declaring two variables, one with the IPv4 that we want to connect, so in this case it would be localhost, and the port we want to connect to, so 30,002. So first things first, we're going to create a socket object, and we can do that with a with statement. So with socket.socket at socket.afinet, for this first parameter, all we're saying is that we're going to be using IPv4. And the next parameter, socket.sockstream, all this is saying that is we're going to have a constant stream of bytes when we're sending and receiving messages, and then we just assign that to a object called client. So in the next line, we're going to connect to the daemon, and we can do this with client.connect. And for socket, you have to encase the IPv4 that you want to connect to and the port in a tuple. So we just do that, and we assign it to the variables that we want. So the target would be, the first variable would be the target, which is the IPv4. That's localhost. The second variable would be the port that we want to connect to, which is 30,002. Next, once we actually connect, remember when we connected to the daemon using netcat, that it sent us a message before we actually started sending anything. And so we want to capture that by just client.receive, and this number is just the buffer size. 1024 is more than enough to capture all the data. So when we capture the data, we'll just assign it to a variable called data. This will get overwritten later on in the for loop. So in the next line, we actually go into the for loop. So for I in range of 0 through 10,000, this is all the possible combinations of a 4-digit pin. And for the first line of the for loop, we send the bytes over. So let's go over this at the beginning, which is the string, or the bandit's 24's password, which is the start. So remember, you have to send the bandit's 24's password at the beginning with a space and then the pin. So with format, we enclose the current, so for I, which would be the number. For example, if this is the first iteration of the loop, I would be 0. So we first turn 0 into a string, right here, using the string function. And once we turn 0 into a string, we then call zfill, the zfill function, to add padding to the 0. So instead of 0, it would be 0000. Then we then ask format to place the newly formatted string into in the middle of these brackets. Then we also add a new line, and this is very important because if we don't do this, the daemon won't really understand when to start checking the password. And the new line is telling the daemon when to start checking the password, because and if it doesn't, then it will just keep receiving messages over and over again, and it won't know when to stop. So that's very important. And then once we do that, we actually encode this message in bytes, and we use the bytes function, and we assign it to the format UTF-8, which is 8 bits. Once we send those bytes, we will receive a message, and we'll decode data. So again, we'll assign the message we received into a variable called data, and then we can decode it with the decode function. So data.encode UTF-8, which is the format that we encoded it to begin with, and if it equals to the message that we receive, if the pin code is wrong, all we'll do is continue. Just skip over it. We know this pin code is not the right one. Let's keep going. But if it's not, and if this message does not get is not, that message, we know that we found the right pin code. So if this isn't true, then it goes to the else statement, and it just prints found password. Here's the pin with the format of the current interval of the for loop, and we print the actual data that we received, so which would be the password, and we'll also print the date time, which is just telling us how long the script took to run, which from my testing it's like 10 minutes, and then we just break. And that is in short how this script runs. We connect to a socket, or we create a socket, we connect to the daemon, and then we just run a for loop over and over again until we get that pin code. And that's the essence of brute forcing. You're just hoping and praying that you get the right combination. This is very useful in the cybersecurity world. There's a lot of situations where you have to brute force. Brute forcing is really a last resort. If you ran out of options, brute forcing is always there. It's always a low-hanging fruit, and you might get lucky, so you never know. It's a very useful thing to have, and it's definitely something that you should have under your tool belt. Now we're logged on to Bandit 24, and we're going to try to run this script and try to find that password. So, just to show you, the second exploit is the improved exploit that I will be going over later on in the video, but the exploit that I just went over will work. So let's just try to run this. Python 3 exploit.py. And from my testing, this takes 10 minutes, so I will skip over until this is done. Alright, so our script has finished, and as you can see, we found the pin, we found the password, and give or take, it took about 10-11 minutes to complete, so it works, and we complete the challenge. This works, like I said, the script will be down in my website below this video. If you're on my website, it will be below, but I will have a link in the description if you're watching on YouTube to my website, where you can find the script and use it for yourself if you want to. And of course, you can try to translate it if you're using another language, but basically this challenge is complete. But I will go over how to improve this, because I'm all for improvement. I'm all for trying to make our lives a little bit easier with the tools we have available. And for that, we will have to use threading. In the simplest form, threading is just having many workers doing different processes at once. So for example, I have two functions here. One is main and one is thread of one. And when we use threading, we'll have both of these functions execute at the same time, and they'll be working at the same time. So in main, I will have it go through, instead of going through all the combinations of a 4-digit pin, it'll only go through half the combinations of a 4-digit pin, because in the first thread, or thread of one, we'll be going through the first half, and then in main we'll go through the second half. And we're doing this at the same time. So the thread one will check 000 first, and then main will check 5000 first, and it will just go up from there. And this is very useful because this cuts down the maximum amount of time it takes to actually crack a 4-digit pin. So I haven't tested this, but I'm pretty sure if we just ran our script the old way and the pin was 9999, for example, it would take a very long time, maybe even close to 40 to 50 minutes to actually crack the pin. And maybe and in this situation where we use threading, we cut that time in half. So if we ran this script, it would actually only the script would execute in the same amount of time as our first script, because the pin was actually 2588, and that is still in the first half. And this is just an example, but you could obviously add more workers and more threads, and you can cut that time in half even more and get the time lower than it really is. But for this example, we'll just be using one thread. So in short, these two functions are the same ones that we were using in the previous script, and they have the same variables. So target is still localhost and target port is still 30,002. So in thread 1, the only real difference in these two functions is the range, which is, in thread 1 it would be the first half of the 4 digits, and in main it would be the second half of the for all the possible 4-digit combinations. And that's really the only major difference. So once we start, if we do if name equals main, which is just checking to see if the file is being ran at the terminal, we create a thread, which is I assign it to an object called a threading.thread, and we name it thread1 with the target of thread1, which is this function. And then we just start it and we start main, and that's all we have to do, really. We also have to import threading to actually, create some threads, and socket obviously to connect to the daemon. So Oh, I already have a script here in my temp folder on bandit 24's account, and that's basically what it does. It just cuts down the time in half. Obviously, it's not going to be faster than the original script because, like I said, the pin uh, is still in the first half. So since this is cutting in half, it will still do it the same amount of time. But obviously, like I said, if you continue to add more threads, it will get you could cut the time even lower than that. You could do it in like 5 minutes, 3 minutes, etc. But one thing to note is Python has a global interpreter lock, which basically means that in threading, oh, only in the library threading, you can only have one thread active at once. And this is mainly used just for testing. It's not supposed to like limit you. By all means, there's multiple libraries out there that let you do multiple processing. For example, multiprocessing is a library that allows you to do this. But threading, the library threading by itself is mainly just used for testing, like API testing, input and output type things. But in this situation, it works for us. It's just an example to demonstrate the power of threading. Uh, I won't run this because, like I said, it takes the same amount of time as the original script, but it will help in the future if, for example, the pin was higher than the first half of all possible combinations. Um, but yeah, that's how you improve brute forcing. Like I said, brute forcing is a very uh, last resort type of solution, and saving in time is always useful. And getting that lucky pin code or getting that lucky password that you get from brute forcing and cutting that time in half is always helpful, and it could help you tremendously in like a CTF or hack the box type situation. So other than that, that's all I'm going to be covering for today. Thank you for watching, and like I said, these scripts will be down below this video on my website, and you can copy them, you can modify them. I really encourage you to play around with them. I also thank you for watching, and I'll see you in the next level.